and ONGC examination. With an active research profile, he has published more than 35 high-quality papers in international journals. His research included nanomaterial, photocatalysis, hydrogen production, etc. He has guided many MSc and PhD students and continuously encouraged young researchers. Today we have honor to have with him as a resource person for this session. I request Dr. Pandit sir, please kindly begin the session.
Thank you, ma'am. It's a great opportunity given by Jagdale Sir's College, Jagdale Sir, Adule Sir, Ahire Sir. So these are like youngest people who are working in chemistry. I would like to congratulate all this staff. As I can see, only this college is producing so beautiful papers, research papers, and so active. They are engaging with various activities. So it's very, or I can say it's your good time that you are associated with this college during this coursework and all. Okay. So thank you very much for inviting me. I'll share my presentation. Just let me know if you are having any trouble with video and audio, then I'll stop my video. I don't think it will be there may be problem because we have good quality of internet now.
Right now it is stable.
Okay, I'll just stop my video then. Is it visible?
Yes, sir. It is visible.
Okay. So as ma'am mentioned rightly, my name is Dr. Vikram Rama Uttam Pandit and I'm assistant professor at Department of Chemistry, Haribhai Videsai College, Pune, which is just situated near to Shaniwarwada. So for today's presentation, it's application based presentation is there. So I have chose organic catalyst, photocatalyst and inorganic photocatalyst and how they can be combined with permutation and combination with the organic and inorganic and can we be able to produce new catalyst for both hydrogen production or like water purification by means of certain organic contaminants degradation that I'm going to focus. So as you might have seen, there are so many presentations, like 6, 7 presentation, and few research papers are also there. So I don't want to make you bore because I know that you can't see me, I can see you, and we are meeting virtually. So don't take attention. If you have any question, you can ask in chat box. We'll try to solve all the type of questions and your doubts. So there are different small presentations. So let me introduce myself first. So we all from India. So see the beauty of our institute or college that in India, we all are from like heart here in Maharashtra. And in Maharashtra, as you go deep, there are so many districts are there. Again, on the same side, there is a Pune district, and in Pune district, there are so many taluka places are there. Again, similar type of, I can say geography is there. In Pune, there is a Haveli at the central place, and everybody knows that this Pune is famous for so many reasons. So Shaniwarwada is one of the reason. So here there is a Shaniwarwada on the map. Here there is a Dagdushet Halwai Ganpati somewhere there, Kasba Ganpati, Lal Mahal is there, and here's Shaniwarada. This is front side, and exactly back side of this Shaniwarada, there is a H.V. Desai College building is there. So let me show you one of the image which is taken from this, like from drone. So this is the front side of Shaniwarada, and exactly back side, if you see here, there is a red colored building is there, and this building is nothing but H.V. Desai College. So in H.V. Desai College, we are having so many courses. This is the website, and we are working under the guidance of Dr. Rajendra Guru. He is from statistics science background person, and we are having so many activities and like instrumentation mainly in chemistry department. We have this FTIR with the diamond ATR. The diamond ATR is there, so we are getting a good quality of spectrums to publish in good quality of research papers. As well as we have UV visible spectrophotometer. So this is the one of the most used machine for this photocatalytic application. As well as we have high pressure liquid chromatography instruments and gas chromatography. So all these are from Shimadzu. All four are working in condition. So as I just had a talk with Satish sir and Adole sir, that so many students, those who are doing their PhD, they are from either they are directly working full time, they are from teachers, they are working somewhere. So we utilize this type of benefit of this all instrument. We learn the instrument first, then our students they get idea how they are working, and we recently we have organized this type of activities during the COVID, not recently during the COVID, and students they used to take classes for this Brazil university, then Iraq university, and some Algerian university. Why? Because they don't have this type of facility at that moment, and so our students they took this opportunity and introduce all these instruments with these all our collaborators. These are the few glimpses from this type of course. And we are having a international collaboration for this purpose only. So most of the things which are present in our college, we are able to showcase on the online platform. Now, after this, I want to show you a very small presentation again, what photocatalysis does in our nature. Okay, so catalysts are there, how to prepare catalyst, how to characterize catalyst, that is different story, and very good team of scientists from science CEMET Pune. They are going to conduct all these type of lectures, or maybe they have taken few lectures, so they will be engaging into that. But I'm not going to go in detail. I just want to give a brief idea about this water pollution. And somewhere in presentation, if you have located on that screen, at the last part of my presentation, I will be focusing on how a rural college based student or PhD research scholar can do this type of photocatalysis with minimal available resources. Okay, so I'm going to give you the procedure actually how we are going to do that. So I just have told you that there are two types of things that we are going to focus on this photocatalysis. First is hydrogen, produce a hydrogen, and second is to reduce the contaminants present in water. So there is a very fine small story is there. As we know that first population increases, so population increase which results into we have to fulfill the needs of increasing population, so that's why industrialization takes place. As industrialization takes place, because of industrialization, so many pollutions that we are going to, it will be automatically get produced with the help of this type of industrialization. So out of these many pollutions, water pollution is one of the biggest challenge. Why? Because this wastewater, it goes into the soil, it again come up through the crops and our water reservoirs. So it is going in our body directly. So it is a problematic. And if you able to see now, I have sometime I have visited to Nashik also. So there are so many bridges are there, and if I can see there are some pipes that are evacuating such type of colored solution into the rivers or any type of water reservoir. So this is problematic. This is not good at all. And the main problem, or from where this we are getting, so we are getting this type of colored solution mainly through the textile industry. So just if you go further to the Nashik, to some Mumbai based companies and Ahmedabad or Surat based companies, they are working, so many companies are working on textile products. So this textile industry generating dyes. So how you are generating, how we are getting this type of troubles? See, here this man is coloring the jeans. So if you have seen a class full of 40 students, out of 40, more than 20 students, they are wearing a jeans. So jeans is like a very common type of garment that people are using. And how they are just giving color, they're just dipping here. Nowadays the advanced techniques are also being came, and once they use it multiple times, and whatever the spent wash is remain after the use, they are just throwing it into the water reservoirs. Okay, so that is a colored, and if you able to recollect what are these dyes, dyes are nothing but complex aromatic structures. All are organic structures, and once they goes into the water reservoirs, ultimately they are disturbing the aquatic life. So the aquatic life, it may be some animals are there and some fishes are there. Again, the severity of this type of dyes and toxic substances is that they don't only kill the fishes, but they may come in contact with these bigger fishes and come in contact with the human being, that is us. See, nowadays what happening, a small kid, when it bonds, within like 1 or 2 years, some of these kids, they are facing the problem of cancer. This is like a very severe problem, and how it might be getting this type of cancer, you may know that these all compounds, organic compounds, they are once goes into the fish body, they are not directly killing to the fish, they are just killing 1 or 2 cells of fish. So once the 1 or 2 cell get damaged, it start to kill the other cells which are present near to it. After some time, it kills so many cells, and there is a uncontrol of cell is took place. So you may know that. Can anybody tell me what is uncontrolled growth of cell? I don't know participants are allowed to unmute themselves or not, but still, when the uncontrolled growth of cell takes place, that means it is a cancer, right? So this type of all cells and fishes, they are getting a cancer. And after that, once human being took this as an food, that time what happens, these fishes and all these damaged organs, they are coming in contact with the human being, and directly they are not responsible for cancer, but they are making a severe changes in human body and their DNA. Okay, so this is very difficult and tedious problem they were facing. And once it altered our DNA replica, then the newborn babies are also they are having such type of cancerous diseases. Now, this COVID, which we have faced during last like 4 5 years, this is the most severe disease or this virus in our generation that we have seen. So there is a report on Nature Journal that this type of COVID, it might be started through the water first. Then it came into the bats. From bats, it goes into the lab. From lab, some scientists they have misplaced something and it come as an very danger problem. So this is the problem, and it's not like that. Some see, there is a problem. So researchers like you, young researchers, they are coming in together and they are setting some treatments to this type of water which is toxic one. For example, physical, chemical, and biological methods are already there. And out of these methods, when we talk chemical methods, we have to use another chemical. So there is a problem. In physical method, we have to filter it. For filtration of a gallons of water, it is not possible, right? So there is a problem. And in biological method, so enzymes and microorganisms people now we are using, so they are already they are like means living microorganism which we are using, and they might get killed. So that is there is again a problem. So this to avoid this problem, there are some solutions that people have chose. Again, when you want to use this type of any processes to treatment the water, that time what happens? We have to have some special type of reactor. Special type of reactors, again, it comes with the cost. So that's why they are expensive and we cannot use this type of special type of reactor. So there is a very fine and very simple solution which is economical, that is nothing but photocatalysis. So here photocatalysis means showed that photocatalysis is nothing but it is a combination of two words, photo and catalysis. We all know that from chemistry background, photo is nothing but a light, and catalysis means the reaction, some part of or some molecule or some powder material we are using, which is altering the rate of reaction, enhancing the rate of reaction. And the advantage of this is that we can regenerate that part. So it is nothing but catalyst, and together we called it as a photocatalysis. So for this purpose, we required a material which we called as a semiconductor material. So if you are able to see this, there are certain materials in physics, some we called as an insulator. So let us consider this position is an valence band. So when we have a insulator material, there is a valence band and there is a no conduction band will come in this range. So it will be so long. Whenever the light falls here or something happens, these holes and electrons, they will not get separate, and electrons not able to go into the conduction band level. That type of material we called as a insulator material. There is a so vast, or in general we can say the material which is having a distance of conduction band and valence band more than 5 6. Okay, so that type of material is known as a insulator type of material. Some materials are there, those are having both the bands, and the band, valence band and conduction bands are so placed close that they can be go into the electrons. When light falls here, they are able to go into the conduction band level. So that means we call it as a conduction. And from chemistry background, again, we know that addition of electron is nothing but reduction, and addition of these vacancies, or we called it as an holes, positive charge, are nothing but oxidation. So there is a redox reaction takes place here. This redox reaction is responsible for depletion of various compounds which are present in the water. So this is the basic of this photocatalysis. One material is insulator, other is semiconductor. So now again, if you are able to unmute yourself, or you can put in chat box, what will be the band position? See, valence band, again I will repeat, valence band from this to a very long, like 10 or more than 10 this value for insulator. For this semiconductor material, it is around like 4.5. Okay, so that is semiconductor. So can anybody tell me what will be the band gap? And this distance is known as a band gap. The most correct definition for band gap is the difference between these two. But the most correct is the upper level of valence band and lower level of conduction band is known as a band gap of that material, semiconductor material. Okay, so there is a insulating material, there is a semiconductor material, and last material are like metals. We know metals, all these material, and we call them as a conductor. So can anybody tell me what will be the band gap of these metals or conductors? Just you can message in chat box. If you are listening lecture, you can put number or something. Am I audible?
Yes, sir.
Yeah, so you just please message something, or you can talk. Okay, so many of you may thinking that, yeah, someone just raised the hand. Less band gap, or ideally zero. Okay, so see, that what I am going to tell you. Very big band gap is insulator, like likely close to this two is semiconductor. And in case of metals, or in case of conductor, there is a no band gap. Okay, they valence band and conduction band, they are just overlap with each other. So just Satish sir or Adole sir, please see chat box is disabled or something. If someone just message. So this band gap is very, very important, and I guess my background is from organic chemistry. And when I saw this, I just remember the photoelectric effect. When this light passes here, the wavelength of that light should be more than this and all. Then and then only electron will come up. So I know that much theoretical part, and I choose to work in this field because of oxidation and reduction world. Okay, so the oxidation and reduction that we know from organic background is different, somewhat different, because it will lead to the different products which are useful, which are maybe medicinal properties. Here we are just using it for the just degrading or removing something from the water. So this photocatalysis is simplest way, and it will not be that means it is economical, and there are different application. First application is hydrogen production by means of H2S. Second is from hydrogen production from water, and lastly the methylene blue or any type of dye degradation. So these three applications are there by using this type of photocatalysis. So maybe I don't know, for today, at least for 2 hours, we are going to talk on these all applications. I'm going to show you how you can do this in your college. This, this is like simplest way to do the reaction in your college. So I will have one case study, this type of compound. This compound name is given as an 613 pentacene quinone. So as I have told you, I am from Master in Organic Chemistry. I got CSIR that time, so I just went to every national laboratories which are present from Delhi to Kerala, and I found some scientists, they with very good research background, very good Google Scholar profile, and one professor, that is Dr. Bharat Kale from the CMET Pune. He just had one meeting, and I went there. I discussed with him. He showed me this compound. Its name is pentacene. Okay, one ring is there. We call it as a benzene. Then second is naphthalene, anthracene, tetracene, and pentacene. 5 rings are there. Okay, so this pentacene is the compound which is used for the makeup of this type of flexible devices. Okay, see, just to mind my words, we are in 2025, in 2027 or 2028, we all will have this type of flexible mobiles in our hand within the next 2-3 years only. Okay, so these devices are made up of this type of pentacene. Again, some of you may working in the solar cell type of field. So one of the layer of this is one electrode, I can say, is made up of again pentacene. Diode materials are also made up of this type of material. Again, some researcher, they use it as it, and some of them, they produce the derivatives of this compound by means of these substituents. These all are substituents, and they have produced so many good papers. Okay, more than 100 papers are present on this pentacene compound in JACS journal only. That is Journal of American Chemical Society. So it is one of the prestigious journal. So you can just replace any of the group and it will give you the different application point, and it will, you have either compare it, means it will be more or less than the earlier reports, and you can do the research. Okay, so this type of plan that we had first. But what is the disadvantage of this pentacene compound is that once I just took some starting compound, I'll show the reaction. Aldehyde and ketone we have just taken and we started the reaction. I got this compound, but what happened? This compound is light sensitive as well as air sensitive. So back then we don't have such type of facility to do the storage of compound. So that's why we settle with some very small quantity of that compound, and rest of the only some impurities we are getting. We are not able to get good quality of NMR spectrum. So we don't have that what we can say, that hood on all for doing this type of reaction. Even Globox was established after some 4-5 years. So for going to this, we how to go from this pentacene quinone compound. So its labeling is like from, it will start from this carbon 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12, and 13. So we did synthesize this compound. So It has certain advantages that it has highest melting point and it is insoluble in various organic as well as in water also. So we settle with this compound. So for this presentation today, or this particular presentation, I'm just going to talk on this compound and how it is used for the photocatalysis. That will part we will cover first, and then we'll go into the some other things. Okay, so what we did, this is already reported in some 1953. So one aldehyde, two aldehyde molecules and one ketone, it will result into this pentasynquinone through a aldol type of condensation reaction. After that, a person somewhere in 2009 just mixed these two and into the warm type of reactor called reaction vessel and just heated it for 250 degree, and without any type of catalyst or solvent he got this. And in the our paper, what we did, we have taken these two in KOH solution and just mix in water and pastel. We got this type of 2D dimensional sheets of this type of compound. Okay, so the route is new, and first time we reported for the this compound as a photocatalyst. Okay, so we know that once you are doing a reaction, any reaction, whatever you have got, you have to prove it by using certain characterization techniques. For organic chemistry, NMR is must. So we've taken its NMR, which matches with the all these reported values of this particular compound. Then there is one more technique, that is XRD, X-ray diffraction. So there are powder standards are given. So PDF numbers are there, and it also matches with the XRD. Luckily, its XRD is available. So we just compared it with GCPD's card number and we got that confirmation. After that, we also performed its FECM, which we called as a field emission scanning electron microscopy, and it got matches with the earlier report. Okay, so we had one setup. So this type of setup is like not that difficult, because why this keeps apparatus everybody from have performed the practicals in F1 SY to find the groups, right? Organic qualitative analysis. That time HCl gas, HCl is taken here and some iron sulfate or any sulfate we are taking. Once the HCl and this reacts, there is a production of H2S gas and we are passing it in 3B group, right? To get these elements inorganic qualitative analysis. So we have used that. So similar conditions we applied, and whatever the gas is produced here, we stored that gas in this cylinder. Okay. After that, this gas is again passing through one of the other cylinder where there is a some material we have taken like barium sulfate or something. Why? Calcium sulfate or barium sulfate. Once the gas is produced, some of the HCl moisture or water moisture, because of the condensation reaction, it may comes as an water vapor may comes here. So to restrict their entry from this cylinder, we have used this calcium carbonate here, and pure gas is coming through this pipe, and there is a one storage for extra gas. If we are getting a how good quality of gas here, so it should get stored, otherwise it will everything will pass to this vessel is known as a reactor, photoreactor. Okay, so photoreactor, it is closed with this aluminum foil because the light is passes on this, so this light will not be making any trouble and it will not go waste. So by considering the like 12 principle of green chemistry, like economy and all, we have kept like this condition. So in this photoreactor, there is a photocatalyst, 100 milligram or 100 milligram catalyst we have taken, there is a water, and whatever the gas is coming through this pipe is kept here. So under the magnetic stirrer, it just making this reaction, and in presence of this is a light source. So once the light falls here, H2S and that semiconductor catalyst, photocatalyst material is there, they are coming in contact and they are producing different reaction, oxidation reductions takes place. And now it is being proved that the hydrogen is only produced by this method. So whatever the gases which are coming through here, they are again collected from out pipe, and it goes into the again similar type calcium carbonate storage. So water is there. So water and the heat of this lamp, it might again combining, and it may produce the some steam, and to avoid that calcium carbonate is used. So whatever gas is there, it is fresh one, and ultimately that gas is lastly passed through this tube into the this idiometer tube. So if you clearly see this idiometer tube is graduated one. So 1, 2, 3, 4 labeling there for ml. And as the gas is coming here, once a bubble comes here, so whatever the water is there, it gets drops down. So per hour we can measure how much micromole or ml of gas that you have produced. Once the gas is stored here, there is a one septum is there. Through that septum, we can just inject here and we can take gas outside, or balloons may be added over here. Okay. And once we are taking this gas outside, we just inject it in gas chromatogram. You will get definitely there will be a peak, and you can just quantify it by the area under the curve, and you can report that. So similar type of setup we means we had there in and we did this H2S splitting by using this. So this for photocatalytic this pentacene, once we use it, it gives us 4,848 micromole per hour per 0.1 gram of the catalyst. So we have to utilize this for this much catalyst only. Okay, so this is like an interesting application that we have performed. Now you may ask that, sir, why we have to deplete this H2S and why we have to produce hydrogen? Because hydrogen, we called it as it's a next generation fuel, green fuel. And recently, like only like 4 to 5 years before, our cabinet ministers and all, they are coming to the parliament through this cars which are powered by hydrogen gas. And not in India, but outside of India, like public transportation is also been taking place through this hydrogen powered cars only. And this hydrogen is green fuel. It is a renewable energy source. To avoid the problem of non-renewable energy sources, this hydrogen is useful. On the other hand, the H2S gas, which is banned, which is toxic one, which can kill to the human being, that we are suppressing. Okay, so H2S gas is coming here, H2S is here, hydrogen is coming. So can anyone tell me what remained in this setup? In photoreactor, what will be there? H2S gas is coming through this pipe, and hydrogen only is going. So what will be the remain? So the sulfur that is which is present in the solid form, it converted into solids and it settles to the bottom. So after the reaction, you can just use that water for agricultural purpose also. So everywhere it is a win-win situation, and so that's why it is a very important method, and we have published these results in very good journal. Now, as we have just discussed, there is a setup of photocatalysis and there is a problem with this. So again, we took that photocatalyst and very small setup. So this you can do in your lab also. There is only a conical flask with a known concentration of any dye, any indicators or dyes that will do the ppm solution. Okay, and you have to put it here. So this is again a setup. Your sir, they have visited CIMET often, so this is again setup from CIMET only. So they have created this photocatalytic setup, reactor setup in CIMET and placed a vertical lamp over there, and it is with the water jacket. So our water jacket, for to avoid the overheating, we are having this type of setup. So in presence of light, this reaction will take place in this photoreactor. Again, you have to take the catalyst and needle you have to place on the magnetic stirrer. After interval, like see 20 minutes, 20 minutes, 20 minutes, you have to take the solution into the small tubes, test tube I can say. After interval of like 240 minutes or 140 minutes, you can see that the color of the individual solution which is there is being getting removed. So there are two phenomena are there. One is decolorization. So you can easily see color. Earlier there is a color and after reaction there is no color. So we call it as a decolorization. Okay, so adsorption can perform this, adsorption can also do this. But to quantify this, we also did is mass spectroscopy. Earlier, the compound has a biggest mass, and after interval 20 minutes, 40 minutes, we have just taken this solution. This is obviously it is a water. So we extracted with some organic solvent and we have subjected to the mass, and we see that there are different small fragments of this compound are there in the mass spectrum. So it is nothing but degradation. So two things are there, two phenomena. One is this particular, we called it as a decolorization, and the true mass, it is known as a degradation. So we had just calculation, and as the MSc part one student, they are also having this type of practical nowadays. So irradiation types against the ln, if you plot it, you will get that how much big dye is remained in your solution at that point, and you can just make a rate constant. You can find the rate constant of this particular reaction to the kinetics. So as you are using per minute, that means you can say this is a pseudo first order type of reaction, and we'll get this type of results from this photocatalysis. Now, see, I'm going to show you this in the next paper, that how you are combining it with the other and how you can do your PhD work. Okay. This is also one coupling system. Other one, first one is composite. What is composite? What is coupling system that I am going to showcase to you? Okay, so this type of setups are there, and one more nanomaterial that I'm going to, you just want to yeah, that part we are going to cover in the like soon. But before that, I just want to know the at least your name of your topics, so that I can focus on organic, inorganic, nanomaterial, or something else. So if the presenter allowed to unmute them, or at least you can just put your topic name in your chat box. You can directly message to me, or you can put it here.
Chat box is open, sir.
Yeah, chat box is open. I can see nano composite preparation. Yeah. Yeah, I'll show one paper for this heterocyclic compounds also. Others, okay, iron oxide, cyanuric chloride, very good. Yeah, making of nanoparticles and decorated on carbon-based material. Very interesting. Just one of my students, she's for doing this work. Okay, so so we'll not to waste our time on this. Whatever the topics I can see here are mostly from, yeah, mostly from material based chemistry and heterocyclic compounds. So I have one report, one paper, and I will show that paper to you. So even if you are going to synthesize by only pure organic way, we have one other way that we called it as an heterogeneous catalyst. You use any type of nanomaterial to perform the synthesis of heterocyclic compound. Okay, fine. 6, 7 topics I can see here. Yeah. Heterocyclic compounds, I know, right? Okay, but just bear with me. My topic is photocatalysis. Okay, and not on the synthesis part, but still it's very simple. So that's why I'm going to showcase you some of the slides which are useful for you. Okay, so just give me 1 minute. I'm just opening other presentation. Huh? Okay, so we came in between this presentation. Yeah. So just I'll finish this first and then we'll go next. Yeah. So after this, what we did, TiO2 is added, then some SNO2 part is also added on this, and we have characterized, we reported some very good result, and I think, yeah, we got this type of project based on this material. So this is the latest work which we have already submitted somewhere. This type of graphs you have to plot. These are some SCM images with IDEX. These are TiO2 and I think iron oxide. Someone just report as a topic of iron oxide. So iron oxide and TiO2 we have synthesis. This marigold flower-like morphology is for zinc indium sulfide material, and these cubes are of nickel nanoparticles. So doping is there. Okay, and these are the some rods of that pentacynquinone powdered, in which is synthesized by somewhat different method than earlier method, and SNO2 particles are there. And lastly, some cadmium-based sulfide and cadmium-based phosphide material that we have also synthesized. These are the TM images. I guess one or two paper we already, yeah, these papers they are published and these are under the review in some journals. Okay, so this type of morphology and imaging you have to do for the publication. This is for water splitting. I'll come again to the water splitting, how it goes with the water splitting. These are the papers. This is the Google Scholar. You can search me. These are my groups and everywhere. And this part that I want to focus, and I want to show you how we are going to do the research photocatalysis at the college level. Okay, so for that purpose, I'm just going to stop this presentation. I have to open other presentation for this. So see, see the photocatalysis, dye degradation is important. In our college, we have developed one of the project in Avishkar competition. My student from like TYBSC, he performed a problem. So while traveling, you might have seen when you are going somewhere and rivers are there. So this type of bigger pipes are there which goes in deep into the river. And what is our thought? Our thought is that okay, somewhere there is maybe a water problem, and yeah, in chat box I have seen some one comment that I have to use mixed language. So sorry for that. I totally forgot. नदीच्या बाजूने जाताना आपण कधी पाहिलं की त्यावेळेला खूप लांब लांब पाईप जातात असं, आणि आपल्याला वाटतं की अरे महाराष्ट्रामध्ये काय प्रॉब्लेम आहे की पाण्याचा प्रॉब्लेम आहे. तर हे पाणी तिथनं येत असेल आणि हे पाईप दुसरीकडे जात होतं, तिकडे ते पाणी जात असेल म्हणून असं असं आपल्याला वाटतं. पण खूपशा वॉटरवरती काम करणारे जे आहेत लोक आमच्याकडे इथे पुण्यामध्ये जनरली खूप साऱ्या काही काही अशा संघटना आहेत की ज्या वॉटरशी काम करतात. अगदी नदीच्या नावानेच त्यांच्या काही काही गोष्टी आहेत, बट आय डोंट वॉन्ट टू प्रमोट यू, बट रोटरी क्लब नावाने काही आहेत. तर ते सांगताना सांगतात असं, किंवा खूप सारे आर्टिकल्स पण अवेलेबल आहे यावरती, की काय होतं, हे पाईप्स जे त्यातनं येत आहेत नदीतनं, ते पाणी तिकडनं घेऊन येत नाही, तर इकडनं काहीतरी त्यामध्ये सोडतायत. यासाठी ते पाईप खूप मध्ये आहेत असं सांगितलं गेलंय. So these pipes are not taking out, but it is giving something inside, and that is nothing but only waste. Why they are going so deep? Because there may be like here, if some people they are using it, so they it may cause any problem to them. So that's why they are not going to just dip here. Okay, so they are just going to somewhere like 1 kilometer or 2 kilometers in this. So here this model it will show you that there is an industry, there in industry is producing some certain useful products. They are stored here. After some 1 or 2 recycle, they are again getting a good quality of product. And whatever the waste material is there, that waste material is transferred and is kept in this black colored jar. Okay, there is a waste. Now it's not like that industry can never throw the waste directly to this river. There is a river. So what they are going to do, they are just storing the waste first, and when they will see that there is no one is observing during the night time, they are just throwing it to the river. Okay, so the pipe which is coming from this waste to the river, that is the main culprit over here. Okay, whatever the waste is produced here, that is already stored. Now the pipe is important. So photocatalysis is so challenging and so important that people they can come and they can work here for the betterment of people only. Okay, so this pipe you have to remember, we will come back to this pipe after some time. And this is the photocatalyst that we are. So I just combined 2 3 presentation, and what I can say that this pipe is important. We are going to work on this pipe. Okay. In our college, we had now developed this setup, and in rooftop of building, we are doing this. Okay. For my MSc student, they are also doing this type of reaction. Now, in our college, what we can do? We require certain chemicals, certain glassware, and some instrument. So the list is given here with some of the photographs. So all these instruments and apparatus are available in our lab. How? See, the apparatus is given here is stirrer. So magnetic stirrer nowadays every college it has. Then there is a conical flask, UV visible. If the spectrophotometer is available, then it is okay. If it is not available to you, you may have colorimeters in your lab. So colorimeter is basic and basic. All the labs, like I think S1 TY student, they are also using this colorimeter nowadays. Next is you have to prepare some dye solution in parts per million solution. So now again there is one question: how to prepare this ppm solution? Can anybody answer first? ppm solution, any ppm. Let us say specific question. I want to prepare 30 ppm solution. How to prepare it? Chat box is open. You can just put 30 ppm. At least you just write yes or no. You know how to prepare ppm or no? Yes or no? See, ppm solution, for preparation of ppm solution, 30 ppm. So you have to take 30 milligram of any that solid of which you are going to prepare this solution, 30 milligram in 1 liter. So that will give you in the ppm, 30 ppm solution. General formula for finding or for making this solution is x milligram in 1 liter is equal to x ppm. Okay, so even I will recommend that for getting a good quality of paper, see quality in our, I guess I will say in Pune University. Okay, for good quality of paper means it should have a good impact factor. Okay, but this is not the case. For Pune University, will at least consider that. Okay, for getting good paper is with good impact factor. So if you want to produce a good paper with good impact factor, that time you have to publish it with at least or minimum 2 applications. So the carbon-based material, nanomaterial combination that can give you this photocatalysis application, heterocyclic compounds which are you are producing from, like if heterogeneous catalyst, inorganic catalyst is there, you can do this application. Okay. And one more, sorry, one more title I think I have seen, the nanocomposite, that can also lead to you this photocatalytic type of application. So whatever you have in your thesis title, that application you perform, but this simplest application at college level you can also perform, and combiningly if you report this, you will get the good quality of impact factor, good quality paper. Okay, so ppm solution, for making any ppm solution, you have to take x milligram of that compound into the what liter solution, you will get that much of x ppm. Then sunlight. Okay, now there is a problem with sunlight for next 2-3 months. After that, there is a very good bright and shine sunlight will be there during the daytime. you have to follow the timings between 11 to 3 p.m. Okay, from 11 a.m. to 3 p.m. This is the most useful sunlight that you are getting. Before that, there is intensity low, and after 3, again, intensity will start to goes down. If you have a physics department in your college, you can just bring any that lux meter. They have lux meter, and if you put it in the sunlight, you will get the actual number of photons. You can calculate that photons, and you can also find the efficiency of your compound. Okay, so that is not listed here because that is not mandatory. So sunlight is free and it is everywhere. Catalyst preparation of catalyst is the main task in any preparation or any type of PhDs. So I guess I'm finding more than 30 students, and they may have different types of topics. So you have to do this. You have to have sunlight, then catalyst, and you have to stir it. Once you perform this, now you have to follow the kinetic part. So kinetic part means you have to take one stand and put the clean and dry test tube over here. You can label them 1, 2, 3, 4, or even 10, 20, 30, 40. After the 10 minutes, after interval of 10 minutes, you have to take the 1 ml of solution into one tube. Okay, after interval 10, 10, 10, you have to follow like this. Okay, so after some time you will see that there is a decolorization or degradation took place here in your reactor. So it's not necessary. Every catalyst that you are taking is reducing the color. It's not the case. If you are producing a nano composite, 4 or 5 catalysts might be there. One may degrade it, others might not. Okay, so this is the case. You have to just do all these reactions with this catalyst. After finding this, you have to take the colorimeter. You can directly measure its absorbance. Now you will get the absorbance values. And if you have a UV visible spectrophotometer, which is recommended, that time you will get this type of graph. So at the 0 hour, means I guess here I have taken 10 ppm of dye. So I will get this absorbance value as around 1.2. After 20 minutes, it goes down, right? So zero point 0.8 or something I'm getting. So absorbance values are these values. Maximum absorbance at that point is known as the these values, absorbance values. So I have to take this value, then I have to take its ELN, then I have to compare it with the 0 value, and it's like just simplest calculations are there. So if some time permits, I may show you the actual calculation, and you have to finally plot the graph. See, even from if you are from organic background or from inorganic background, you must have the origin software. So I guess I have seen some softwares in your syllabus. So origin is very important and simple type of software that is used for plotting the this type of beautiful graphs. Okay, so if you have this facility at your college, you can perform this photocatalytic application. Now, okay, so this dye degradation is nowadays it is a routine. Everybody is performing this. What you can do extra? So if you know the phenolic compounds are there, chlorophenol, chloro 1 chlorophenol, monochloro, dichloro. Okay, so this type of chlorophenols are also been banned. They are toxic in nature. You can perform this. And mostly, if you have biotechnology or microbiology type of department to take a safety in account, you can bring any type of pesticides from the market and you can do this type of reaction. Okay, so pesticides ते बी बियाण्याचे दुकानं जे असतात तिथं मिळतात पेस्टिसाइड्स. सो ते प्रिकॉशनने थोडंसं जर घेतलं आणि त्याचं पीपीएम सोल्युशन तुम्ही बनवून जर ते जरी डिग्रेड केलं तरी सुद्धा हे खूप चांगल्या प्रकारचं ऍप्लिकेशन आहे. सेम फोटोकॅटॅलिसिसच इथे वापरायचं आहे आपल्याला. आणि लास्टली द फार्मास्युटिकल टाइप ऑफ ड्रग्स विच आर बॅन्ड. People, they are taken the paracetamol as an also one of the drug to degrade this. Some of the compounds which are really banned, which are toxic in nature, you can just simply take this compound instead of this dye ppm solution, prepare a different ppm solution. You have to follow the similar process. So see, all these applications are different. Even if you have two application, you will be producing good quality of paper. I will means more than two, it will be like a good. And if you have good quality of catalyst, then you will definitely get very good publication. Okay, so very simple procedure is there. You have to take a stirrer, keep a conical flask, add the ppm solution over it, and stir it. Now the stirring part is again two parts are there. You can use the natural sunlight which is available everywhere now. But if you don't have sunlight, you can simply have a bulbs, different watt bulbs with different wavelengths. Bulbs are also available. You just put the bulbs over the this conical flask and you will do this type of reaction. Some of the research group, they are doing this type of reaction in petri plates. So that is not scientific. Don't use that petri plate and all. It will not give you the good quality of result. But this is like a highly recommend because the catalyst is maximum catalyst is coming in contact with the dye particles. When you have a round shape of that petri plate, that time what happens, your catalyst is going only in the periphery of that particular petri plate, and in the center there is a nothing. Here in this case, because of the magnetic stirrer, everything is coming in contact with this catalyst as well as in the dye, and that's why you are getting a uniform, or I can say is scientific results. Okay, so this is the case. You have to do this type of reaction, and if you start the reaction, if you get any problem, you can feel free to contact me at any time. Okay, for this calculation and graph, I will show you how you can perform it. In our lab, we have this already. You may have this U visible spectrophotometer, that is important. Before going for the UV, when you are taking a solution into this test tube, you are getting a dye and you are getting some of the particles of the catalyst also. Okay, nano material, if it is there, organic material is there, that will again come here. If you subject it to for the UV visible, that time what will happen? You will get a spectrum for dye as well as you are getting a spectrum for your compound also. So to avoid this, there is a centrifugation machine is available. You can simply put it in centrifuge and it will get settled. Whatever the catalyst part is there, it will get settled, and only the solution of dye that you can take and you can label the its absorbance here. Okay, so this mass that I am talking about, the photocatalytic, how we can confirm. Okay, so when you have this, lot of reviewers are there, they are asking this type of question. Okay, you are saying that it is going to get degraded, but why not degrade? Means why it is degraded and why not it is decolorization? 100% there is a question. Even I heard in so many PhD vivas that and students, they are unable to give the answer for this question. So for that purpose, take the first solution and last solution. You just take its mass and CMS will do. This is the initial compound, so it will be there is a mechanism and it will give you different type of fragments, and that fragments will give you different types of peaks. How the compounds get degraded, this is the mechanism, and the last how it will goes means how for what extent it will degrade. So to form like carbon, CO2, then water, N2O. So some people will say okay, this is toxic, no doubt, but you are producing CO2. So the concentration of CO2 is here very, very low, and its effect is very, very less as compared to this starting compound. Okay, so that's why this is, even human beings are also producing CO2. So that's why it's not that much problem. So you can utilize this for this mechanism, and it will confirm this. So what is our aim once you do this? So now there is again our problem. So whenever you are getting any product, the waste which we are storing is coming to this. So the main villain for this particular work is nothing but this pipe. So when you come in the contact with some of the chemist, microbiologist person, some engineers, some physicists, so all they will come together, and what they will do, they will be making an engineering on this pipe. So how we have to do that? So I have a cross section of this, and this is just already people, there are a lot of work on this pipe. So we are also with the some of the research group collaborator, we are also working here. What we have planned, that near the river, when we have this pipe, so there are two ways. Either you can take a glass pipe. So glass means not like simple glass. Some glasses are so tough that even when human beings are also can walk on that glass easily. Okay, so that type of glasses, if are available in the natural sunlight, there may be this type of thing we can do. Or else if the metal based pipes are there, so after interval, so though these are looking so close to each other, but it's not, there may be some meters of distance will be there, few meters distance will be there. So what is our this thought on this is, if we have a chips made up of with this photocatalyst, we will place here. And it's not all the chips. Some materials are with the carbon base. If you know the charcoal or some material which are carbon based, that can be alternatively placed in this pipe. So when the wastewater will come here, it might be anything. It might be having some biological waste also. It might be having organic waste also. So when it comes here, some of the this charcoal based material that will absorb it. Okay, and rest of the water which is going, that will come here, and in presence of this light, either natural light or this light, it will making a degradation here. So the part which is degraded and adsorbed, that will be different. So we are not sure that we are going to purify 100% this purification of water, but it, if it is having a 100% polluted, we have assurance that if it is 100% polluted, it will definitely not a 100% polluted over here. Okay, and these chips can be replaced by certain other materials also. So it can be replaceable. We can change them with some good quality of materials, photocatalytic material, from TiO2 to any organic compounds, or like carbon-based material, charcoal or graphene-based compound, that can be perform this. Okay, so this is the photocatalysis, I can say, futuristic approach. People already reported, so many literatures are available on this. Okay, so this is the aim. So for PhD, we have to have these chips, and whatever the material is present on this chip, that I am going to synthesize, that I'm going to tell you now, that how one can perform this composite formation with very simple way. Again, very simple college where there is no any master lab or no research center is available, they can also produce this type of composite in their lab only. Okay, so that type of one paper and 2-3 slides I want to show you in the next presentation. Okay, so this is the problem, and this is the photocatalysis is one of the solution for this purpose. Now let me share you the other slide for this. I guess I'm getting messages after some time. I don't know. You already answered correctly. So just I'll take a break of 2 minutes, and again I'm sharing presentation. Just 2 minutes. So sorry for the So for this preparation of nanocomposite, I'm not going to go into direct that procedure. Okay. But I will not say the synthesis of nanocomposite. I can label my topic of this particular presentation is like this: how to publish paper soon. Because see, I know like more than like 20 people now they are doing PhD here and there, and they are so frustrated that they are not getting any paper. Their work is stuck somewhere, and more than 50 guides are there. Okay, more than student guides are there. They are saying that their students are not working, their students are not coming, and they are not completing their work. So for this, to avoid this, you have to see this one paper. Just a minute, I'm opening that paper first. Okay, so this nanocomposite formation. So if you have any there is a title in of your PhD and aims and objective slide you have prepared for your pre-synopsis or first presentation, pre-presentation for your joining of PhD, right? So that time you must have some compound, and that compound's activity you have to check. So for nanocomposite, what we can say, nanocomposite are the compounds which are when mixed somewhere, like nanocomposite, the matrix, okay, to which a nanoparticles that are added. For example, if you have plastic and glass, two different things are there. Nowadays glasses are so tough that we cannot break them through the stones also. So why? Because there is some composites are being made, some threads are put in the glasses as well as in plastic, some particles are mixed with that, so that is nothing but the nanocomposite. And once you have this, it will directly getting a good quality, it will speed the reaction type, it will add the toughness in that product. So that's why making this nanocomposite is very, very important. For example, if you have any parent compound means someone have posted only nanocomposite, someone posted Fe2O3, someone posted some carbon based material. So carbon based material means either it will be graphene, it will be nanotube or something else. So what is nanocomposite? If you have a graphene, for example, and if you are adding nanoparticle over the graphene, so the whatever the compound resultant compound is we are producing, it is a nanocomposite. And if it giving us a good quality of results are elevated, that means we call it as a nanocomposite. Okay, so this carbon-based materials properties you are enhancing through the composite. So this is important. This is we call it as a composite. Okay, so it will get a properties are getting more and more. So we already seen that 613 pentasynchinone is one of the compound that is being reported as such. Individual compound is there. Now TiO2, SNO2, and all this compound. First time that Michael Gratzel, he have published one paper in 1972 on this TiO2 or water splitting. So what he did, he just utilized this TiO2. So TiO2 is best inorganic material till date for the photocatalytic application. So we had this pentasynchinone and we thought that why we are wasting our time over pentasynchinone. Only single compound gave us a very good paper, but our approach is different. So we prepared nanocomposite of this with the help of very simple method. So again, see all these apparatus you must have in your lab. How we did and how you can do same thing that I'm going to repeat. See, one compound that is TiO2 and other compound is pentasynchinone. I want to increase the properties of pentasynchinone. So what I did, I have made a solution of 5 milligram of this pentasynchinone on chloroform in 100 ml of chloroform. That solution I have prepared. Now I know that, okay, it is like a 50 ppm type of solution, but no, I don't want to go into the calculations as I am from the organic background. The simplest way, you take 100 milligram in 100 ml, 100 ml chloroform, 100 milligram of the catalyst. That means that solution we call it as a 100% solution. Okay, 100 milligram in 100 ml of chloroform. Why? Because 1 milligram will come into 1 ml. 1 ml solution will have 1 milligram of that catalyst. So that type of solution we called as a 100% solution. Now I have a TiO2. So I have taken the TiO2 which is already available in the market, Aldrich TiO2. And I disperse that TiO2 in three A, B, and C. Three beakers, three different beakers and three different stirrers I have taken. I labeled them as a, B, and C. Okay. In the beaker, I have put 1 gram of TiO2, same TiO2 in each 1 gram, 1 gram, 1 gram. Okay, and now it's under the stirring, chloroform is taken, 20 ml of chloroform is taken. So slurry will become, the chloroform is having very less boiling point, so it start evaporating. During that period, I have prepared the 100% solution. Please note that this method is known as a wet impregnation, WEIGHT, wet impregnation. Weight means weight by weight, I am going to take this as an percent. So that's why we called it as a wet impregnation method. Weight is different, WET weight is different. So this method is known as a WET, wet impregnation. So both are like weight and you are impregnating one over the other. So TiO2 is already there in solution. I have prepared the 100 milligram of that compound in 100 ml of chloroform. So if I take 1 ml, it will go 1%. But similarly, during that time, I have taken 1 gram of the TiO2. So that's why that is not making it as 1%, but it is making it as an 0.01. Why? Because this is not 100 milligram, but it is a 1000 milligram of TiO2. So the calculation is apart. You just have to put like a 1 ml, then 10 ml and 20 ml solution of that pentacynquinone to this. That solution is also made in the chloroform. The earlier solution is also made up in the chloroform. So chloroform eventually it will get evaporated within like couple of hours. Even if some slurry part is remain, you can heat it, simply heat it within like 230-40 degree also, the chloroform will go out. And whatever the compound you settle with, you have to collect it, you have to have a mix it in the mortar and pestle and then collect it. Simply you will get the composite of this TiO2 and pentacynquinone in the weight ratio of 0.08%, 0.1% and 0.2 weight percent of pentacynquinone. Pentacynquinone is not that economical and that's why we have taken in less quantity. TiO2 we have already, we had it in good quantity as well as we have that good fine Aldrich TiO2. So that's why we have taken that as in the more quantity. Then whatever the solution we prepared, we have just evaporated it naturally first, and if required, then and then only we have heated to it. Whatever compound we prepared, that compounds we labeled as an again A, B, C. So now I have 5 catalysts. Okay, A, B, C, these 3 catalysts and TiO2 as such. TiO2 is 4th and pentacynquinone is a 5th. So 5 catalysts I have prepared and then what I can say, okay, this catalyst I have prepared. Now they are simply mixed together. So there is no chance of getting any extra reaction or something. So you have to characterize it. So if you see in this XRD, this is the pentacynquinone, this is the TiO2. This type of graphs are known as a stacking and it can be performed in the origin software again. So TiO2, no doubt TiO2 is more in quantity, so everywhere TiO2 is seen. But this pentacynquinone, we are increasing the quantity, so that's why the pentacyn peaks are a little bit more as compared to these two here. So that confirms the formation of this type of composite. But more clearly, we already have seen it is a flex type of compound pentacynquinone and TiO2. We already know that this is taken from the market, so its size is already given. So these circular particles are nothing but the titanium dioxide type particle. Earlier, they are having this type of distinct type of morphology, but when we mixed it together, when we stirred for like couple of hours, they found as an accumulated here. Okay, after that also we perform its TEM. So here pentacynquinone sheets and TiO2 particles can be seen over here. And this means these two are like mixed together with this method. And U visible is nothing but the, I can say this is the most promising way to find the nanocomposite is form or not, because the position of this is shifted as you are adding. This is yellow color TiO2 which we are used here. TiO2 is a white color, or we can say white color, and this is yellow, so it is shifting toward right side. Okay, so that's why we can say there is a, okay, composite is been formed and there are no any extra peak. This peak is for TiO2, this peak is for pentacynquinone. So photocatalytic activity, same photocatalytic activity type of perform, we had used that setup which I have just now discussed, and you can see pentacynquinone and TiO2, they are having a good quality of rate, but as the pentacynquinone is added over the surface of TiO2, the rate is enhancing. After this 0.2%, if I took any other concentration more than this, I found that the rate remained the constant. So that's why we stop over here 0.20, and you have to find the rate and by the calculation, and you can report it in this. We did its recycling study. So this type of method we called as an composite formation. We published in RSC Advanced Journal. So this is like open access. I guess it is available to everyone. Now this one is composite. Another one method is there is a coupling. This coupling method means what? You know lot of semiconductor materials. You know their valence band and conduction band position. So you have to choose two for coupling so that the valence band and conduction band of other, valence band of one and conduction band of other, they must be separated by some distance. If you have choose these two materials, then what will happen? The holes here form holes will remain here, but electron will go here, and the electron will again recombine into the holes which are formed in the other material. So there is a condition. You have to find this type of material by using this. Okay, these are the semiconductors band gaps, and you can find the semiconductor band gap by using this Tau's plot, as well as cyclic voltammetry is also there. Okay, so many already they have performed this type of semiconductor coupling, and reports are also available. Okay, so for this particular synthesis, what we did, we have synthesized TiO2 here. Now in earlier case we utilize the Aldrich TiO2. Now we don't have to use that. I prepared my own, and during the synthesis only, in the that autoclave or hydrothermal setup, the solution which is made earlier, that solution of pentasynquinone is added, and then this hydrothermal is locked and then heated to 150 degree. Okay, so pentasynquinone is melting point, if you remember, it is around 400 degree. In 150, it remain as it is, and there is a formation of this coupled system. So we again confirm it with the help of this characterization techniques. But when we found its TEM, transmission electron microscope, I don't know you are getting these images as clear or not. These are the rods of these sheets of pentasynquinone, but over the surface, a very tiny particles which are having a size of less than 10 nanometer. We called it as an quantum dots. So that quantum dots been formed over here, and we have not utilized it for the dye degradation, but we used it for H2 splitting. And as the pentasynquinone concentration is increased, the hydrogen production is also increased. So this paper we published somewhere in Journal of Material Chemistry A. So this is like again very standard type of journal. So these two things are there. One is coupling and another is composite making. Both are good for getting a comparative results. And if you have comparative result, then and then you only you can write a good manuscript within like few days, and you can publish it in good quality of journal. Okay, so for today, just I guess I think dye degradation part and photocatalytic setup for the dye degradation that we have seen. So for this particular topic, if you have any question, you can ask me now.
Now the session is open for question answer. If you have any question regarding this topic, then raise your hand or drop down your message into chat box. Please ask the question. Sir, there is one question that
Yes, sir.
Nitin,
Yes,
sir,
ma'am. Yes, ma'am.
that how graph can be drawn on laptop?
See, this is a irrelevant question to our topic, but still I'll ask. I'll answer this. There are for different type of graphs, the instrument it will give different type of data. For example, if you want to put graph for UV, FTIR, XRD, Raman, okay. So this you are getting a data in two form. One is an ASCII, another is a text file. So if you have that data in text file, you can also plot it without any software in the Excel. Okay, simply just open that data in Excel in two columns, select that columns and just click on the insert tab. There are graphs. So select line graph, you will get the graph. This is one thing, and I guess there is a origin software is there which is not really available everywhere, but still if you have iCard, student iCard, there is a free access of, I guess, 45 days on the official website of this origin. Okay, just see. Earlier it was there last couple of months. I have seen that if the same type of offer is going on, only condition is there that you have to use official email address. म्हणजे जर तुम्ही कोणत्या रिसर्च सेंटरला जर अफिलेटेड असाल तर तिथलं किंवा तुमच्याकडे जर असेल gmail.com yahoo.com हे चालत नाही त्याला त्याला कुठलं तरी ईडीओ असेल किंवा एखादा ORG चा मेल जर असेल तर त्याला ते चालतात आणि तुम्ही तिथनं ते ग्राफ प्लॉट करू शकता सेव्ह करू शकता डेटा असं आहे.
Yes, sir. So there is no any other question in chat box.
Okay, what I will do, I'll just put my email address in the this chat box. If anybody have question, they can just mail me.
Yes, sir. Yes.
Yes. Yeah, you can just message me.
Yes, sir. Yes. Now the time is for vote of thanks. I sincerely thank you, our today's guest, Dr. Vikram Pandit sir, as well as our college principal, Dr. B.A. Jagdale sir, for kindly support this program and encouragement of such a type of variety of programs. I also thankful coordinator of this program, Professor Dr. T.B. Pawar sir, all the teachers and all research scholars for their help and contribution. which made this course successfully. Thank you so much, sir.
Thank you, ma'am.
Yes, sir.